Welcome to Ask and Learn.
This is the answer to Chapter 20, problem number 49 from the Smith Organic Chemistry textbook. And this problem asks us which carbon is most electrophilic in molecule Y. And we're asked to explain the choice that we make. And so I've redrawn molecule Y here at the top of the screen. And so basically, we're asked which carbon is the most electrophilic. Remember that an electrophilic carbon is going to be a carbon that's unequally sharing electrons with an atom to which it's bonded. So it's going to be a carbon bonded to a pretty electronegative atom. And so in this case, we have three carbons that are bound to oxygens. So we have this one, and this one, which are the two carbons that are part of our carbonyl. And then we also have a third carbon bound to an oxygen, which is this one. This carbon is bound to the other oxygen in this lactone. We can pretty safely ignore that green arrowed carbon. It's going to be somewhat electrophilic, but compared to the two carbons that are part of carbonyl groups, it's not. Those carbons are going to be much more electrophilic. And so to determine which of the two red arrowed carbons is more electrophilic, we are going to have to look at resonance structures. So I'm going to draw these. I'm going to omit the other ring in each case that's not part of the resonance structure, because why redraw something that is not taking part in what we're showing? So for the carbonyl on the left, the carbonyl that's part of the lactone, we can draw three resonance structures. So we have this first one. We can draw another resonance structure, and I guess let me put my lone pairs in here. So we can draw another resonance structure where the electrons of one of the two bonds of the double bond revert to this oxygen. So we have a resonance structure that looks like this. And that doesn't look very good at all, does it? Okay, so let's try that again. So we have a resonance structure that looks like this. Okay, where we have a single bond here. And this oxygen has three lone pairs and a negative charge. And this carbon is short an electron, and so it has a positive charge. And then we can draw another resonance structure where this other oxygen, one of its lone pairs, adds here. And so the result of that is going to be this third resonance structure that's going to look like this. So now we have a double bond here. And this oxygen is going to have one lone pair and a positive charge. And this oxygen is going to have three lone pairs and a negative charge. And so the thing to notice about these three resonance structures is there's only one where the positive charge is seated on the carbon. And that's because the other oxygen can donate some of its electron density. And so when we look at the resonance structures for the other possible most electrophilic carbon. So for that, I'm just going to draw the other ring, the right side ring. So we only have two resonance structures here. So we have our first one where there are no charges and there's a double bond and the oxygen has two lone pairs. And then we have the other resonance structure, which is going to be where electrons from that double bond revert to the oxygen. And so here we have three lone pairs on the oxygen with a negative charge and a positive charge on the carbon. And so there's no other oxygen here to donate electron density. And so these are the only two resonance structures that we have. And so because of that, we can say that that this carbon is more electrophilic because we only have one other resonance structure, and in that resonance structure, it has a full positive charge on it. And so after comparing, these two sets of resonance structures, we can say that the carbon in the right ring is going to be the most electrophilic. And again, we got to that answer by looking at the different available resonance structures for each of these carbonyl carbons. And that is the answer to chapter 20, problem number 49.